Welcome to EDU World Space.
We'd like to know the values of C that allow the series to converge. So here, one option is to go ahead and try the integral test. Another option is to just proceed algebraically as follows. So here, let me go ahead and just rewrite this. C is C minus 1 plus 1. And then I'll split up some terms here. C minus 1 is constant, so I can pull that out. Notice that this first series over here, this is a telescoping series. And this can be evaluated. And we will actually see that this series converges. So let's just focus on this series for a second. And let's rewrite it as a limit k goes to infinity. Now let's go ahead and evaluate that partial sum. Okay, we would keep going all the way until you plugged in. Let's maybe do a few terms before k. Let's do k minus 2. And then k minus 1. And then k. And now we should cancel as much as we can. So we see the first term will stay there, the 1. But all these intermediate terms cancel out, even all the way until you get to k minus 1 and k. However, this 1 over k minus 1 will also stay. So you just have the 1 and the final term that stay. And when you take the limit, this fraction or this expression goes to 1 because the fraction goes to 0. So that shows that this sum is just equal to 1. So we can rewrite the whole expression as 1 plus c minus 1 sum 1 over n. However, if you look at the other series, I'll circle this in black, this is harmonic. Or you can say it's p series with p equals 1. So this diverges. So unless we want this series to diverge, we should go ahead and take c equals 1. Because then that'll wipe off this here, and that'll ensure that our sum converges to just the number 1. So converges if and only if c equals 1.